Welcome to our final project, Nutrition Tracking. I am Violet Goforth.
And I'm Barsha Angdembe Subba. We are students at Texas Women's University.
For our database systems course, we were tasked with designing and implementing a nutrition tracking database.
In this presentation, we have 6 main sections, beginning with our project description, goals, and benefits.
We will then take a look at our ER diagram and review our 10 queries that we ran.
Afterwards, we will discuss the challenges of this project,
followed by a reflection of what we've learned in this course. Let's begin.
Our project had us design and implement a nutrition tracking database for our users.
It is designed to help users track what they've consumed and their workout routine by collecting and analyzing qualitative and quantitative data.
Our database stores data in 5 tables: user, health, nutrition, food diary, and fitness diary. For this project, we added 20 rows of data for each table.
We view the app as a source of motivation as users document calories consumed and burned. A benefit of the app is educating the users on nutrition of the foods they eat. When logging a meal, the user will see the nutritional facts of what they just ate.
Our app strives to empower the user to gain a deeper understanding of how their body works while meeting their personal goals.
Perhaps a user never knew how much sugar is in one serving of peanut butter or an apple until they've used our food diary.
A user could also learn how many calories are burned during a 2-mile run or planking for 3 minutes.
A lot of people will thrive with the routine of checking in daily to this nutrition app and tracking their personal progress to meet their individual goals. Our ER diagram displays each one of the tables, lists its columns, and expresses the data types. It is our graphical representation of our entity relationship model.
First, tables are created and populated in the WP database tables. To create an entity relation, we go to Database menu and click on Reverse Engineer.
The lines connecting the related entities represent their relationship to each other.
The symbols at the end of each line display the cardinalities of the relationship.
These cardinalities let us understand how many entities of one kind relate to how many entities of another.
For example, in our ER diagram, we can see that the user entity has a mandatory many relationships to all tables besides the nutrition entity, where it has a mandatory one.
Let's begin by discussing the queries we were able to run in our database. Our first query was a simple select statement with ordering.
We ran the following code: select asterisk from user order by first name.
This query returned all records in the user table
and ordered the data alphabetically by first name.
Our next query utilized the composite condition to display the user whose age is between 20 and 30 years old along with their goals. We ran select count user ID age goals from health, where age is greater than or equal to 20 and age is less than or equal to 30, grouped by age.
As an aggregate function, we are using the count function. It returns and labels the number of records for this query. The group function lists the result by each age beginning with the youngest.
As you can see, the output shows the results from the query. For example, there are two 21-year-olds that have the same goal of maintaining their weight,
and one 29-year-old who has the goal to increase their endurance. This represents the qualitative data of our nutritional database. The third query we ran was a calculation for body mass index of the user with the largest weight in pounds in the health table. To represent the largest weight, we use max as an aggregate function.
We use the body mass index formula, which can be seen on line 223, and calculated BMI.
The resulting output was a body mass index of 25.8219 for the heaviest user that weighed 223 pounds, 223 pounds.
Moving forward, this next one is a subquery.
First, subquery executes select user ID from fitness diary where set is equal to 4, returns user ID from fitness diary, those whose sets is 4.
Then the outer query executes it and returns the dietary restrictions, illnesses, and goals from the health table of the user whose user ID is returned from the inner subquery.
As you can see our output on this slide, every user that performed 4 sets of an exercise is retrieved along with their dietary restriction, illnesses, and goals.
In this next query, we have interjoined the food diary table and fitness diary table using user ID.
Here we are displaying the data of the user ID and the food consumed by user under food name,
as well as the exercise they did and the amount of calories burned during their workout.
Running this code only retrieves the records in which the calories burned were greater than 400 during a workout. This is because our SQL code use of a where statement.
This next query is a right outer join. Unlike an inner join, which relates rows in both tables, outer joins also include rows with no related rows.
The right outer join selects all rows from the table on the right, which includes rows with no related matches from the table on the left.
To rephrase, the right join keyword returns all records from the right table, which in our case is food diary, along with only the matched records from the left table, which is nutrition.
The displayed results are in ascending order for data consumed. For query 7, we created a view table named Food Consumed and Workout. It is a virtual table and contains the columns from Food Diary and Fitness Diary.
Here, we have created the column that contains food name and user ID from Food Diary, as well as exercise and calories burned from Fitness Diary, which were interjoined.
Also, there is a condition which displays from the dataset only records which the calories burned were greater than 400.
In this next query, we use the union operator. We have selected the food name column from Food Diary and Nutrition.
The union operator selects distinct value from each column and does not display duplicate values.
You can return the results of multiple queries as one combined query by using union. For our next query, we created a stored function.
And user defined the function by using the command create function.
Body mass index is the name of the stored function. Weight in pounds and height in inches are the arguments whose value is used by the function inside its body.
We are calculating the BMI of the user and it is declared as an integer.
Our final query was a custom stored procedure.
The following SQL statement created a stored procedure that selects the last name Miller from the user table.
A stored procedure can be stored for later use and can be used many times. This project, we put into practice what we've been learning all semester. However, we did face a few speed bumps along the way.
While adding records of data into our user entity in SQL, we received error messages. We had some trouble figuring out why our code wasn't correct.
Upon further investigation, the professor's schema had a user table already that we didn't have access to. So we had to specify a specific schema in our SQL code.
We needed to change the code to reflect our user ID. Another challenge we came across was figuring out how to update records that we ran with an error in it.
Yes, like a misspelled word. I wrote an insert statement to record a log for a user's goal in the health table. I ran the code and then immediately realized that I misspelled the word strengthening. I actually ran the word strengthening and realized maybe I should stop coding for the night and go to bed. The next day, I worked it out to update this user ID's record like so.
Don't worry, it happens. Luckily, we were able to update it. Another challenges we faced was writing stored function and stored procedure. Here, we faced an error code which is error 1418, and it was saying we didn't have any determinist. While adding a query for determinist, we still faced a problem. It's error 1419, and it was about super privileges. After a few setting adjustments by professor, we were back on track.
Our database systems course has provided us with the basic foundation of reading, modifying, and formulating SQL commands and functions to retrieve data.
We were taught how to use SQL to create tables, views, and indexes.
We have learned how to read and evaluate a relational database model,
as well as understand an entity relationship database model. We have learned about concurrency control and recovery,
and about the importance of database integrity and security,
database management techniques and evaluations,
as well as database management system structure and maintenance, and much more.
The skills we walk away with are going to serve us as we branch out in the job market.
Thank you for watching our presentation.
Thank you.